Hello again. This is Math 2232 coming to you from the College Ed page. And the title of this lecture is Solution to the Arc Length LSA. As always, please be attentive learners while watching this video. For completeness, let's restate the LSA. So you were to find the exact arc length along the curve given by y squared equal x cubed from the origin 0, 0 to the point on the curve where the tangent line makes an angle with the x-axis measuring 45 degrees. Continuing with by way of introduction, it's often useful to look at the curve, and you can see that we're trying to find the arc length from the origin here to the point on the curve where the tangent makes an angle of 45 degrees with the x-axis. Now notice that there is a point up here where that happens, but there's also a point down here where that happens, but the symmetries of the problem indicate that the arc length, either from here up to that given point or from here down to that given point, will be the same. So we can simplify the problem by exploiting those symmetries. I think I'm repeating what I was saying, but that is useful. So observe that the problem has symmetries rendering it acceptable to consider only the y bigger than or equal to 0 portion. Now in this restricted region, we have y squared equals x to the 3/2, which reduces to y equal x to the 3/2. And then, because we know we need to have the slope of the tangent line equaling 1, and in this case, and we also know that we need the derivative for the arc length formula. So we're going to take the derivative of this y equal x to the 3/2. So it's going to be 3/2 x to the, we subtract 1 from the exponent. So dy dx is found to be 3/2 x to the 1/2. Now, we are seeking an x0 on the curve such that this tangent is equal to 1. So we're going to call it x0. So we want to find x0 such that 3/2 x0 to the 1/2 is equal to 1. Now you can solve that by squaring both sides, and well, first of all dividing by 3/2 and then squaring both sides. So you get x0 has to be 4/9. And you should notice that the point on our curve then is 4/9, comma, and the y is found by substituting in here, so that is 4/9 whole to the 3/2. And I'll plot this point later, but that's the point that we want. But the x value is 4/9. So we know that the arc length requested then is the integral from 0 to 4/9, because that is the point that we needed, and this is the square root of 1 plus dy dx whole squared dx. And we know that dy dx is this, so when you square it, you get 9/4x. So this integral is going to be the integral from 0 to 4/9 square root of 1 plus 9/4x dx. And of course, you are being asked to evaluate this integral in addition to setting it up. Okay, so a way to do it is to let u equal 1 plus 9/4x, and then du is equal to 9/4 dx. That means that dx is 4/9 du. You don't have to do it this way, but it is a way to do it. And as I've discussed previously in this class, if I've done a u substitution, I want my I will do my limits with u's. So as x goes from, this is dx, so as x goes from 0 to 4/9, x goes from 0 to 4/9. U will go from, well, if you put 0 in there, you'll get going from 1, and if you put 4/9, you will get 1 plus 1 is 2. So u goes from 1 to 2. So if we do that change of variable, dx will become 4/9 du. I pull the 4/9 out of the integral. I'm doing du now. This is the integral from 1 to 2 of u to the 1/2 du. Okay, now this is going to be u to the 3/2 divided by 3/2, which is the same as multiplying by 2/3. So this is 4/9 times 2/3, and I have u to the 3/2 evaluated at 2 and 1. And here you get 8/27, so I put 8/27 there. When you put 2 in, I get 2 square root of 2, and when I put 1 in, I get 1. So this is the answer. Now this is the exact answer, so this is what was asked for. But if you're pounding this into a calculator, you would get something like this number. Again, returning to the graph, I'm plotting the 4, 4/9 whole to the 3/2 there, and doing the tangent line. I figured out what the intercept was, and so on and so forth. And this is just checking my work, but this is the same number. It's written differently, but if you check it, it's the same number. And so that is the answer. I always check to make sure if a student writes a number differently, but it's the same number, I of course will count it right. In closing, now more than ever, time is precious. Each day must count. Do the math, it will make you strong. And now more than ever, take care of yourself, because self-care is important. And now more than ever, take care of each other, because we're all in this together. Strive to make a difference. Look forward to seeing you guys in class, and God bless you all.